Hi everyone, and welcome to day 3 in Advent of Rust. Today we are going to talk about struct, function, as well as modules. So stay with me and let's dive into the struct. So we're going to use a pizza data structure to store, retrieve, delete, and insert. So let's start by using the struct keyword, which will tell to Rust that, hey, we are going to create a new data structure with maybe one field, which will be a name. So cool. Now I have a new object, which is pizza, with one field name. As you can notice, pizza is never constructed. So let's create one. Going to get rid of that, and I'm going to create a pizza. It has a name. It's going to be a string, my pizza. Cool. No, maybe I want to print it. So I'm going to use print. My pizza name is, and in Rust, we want to add curly braces to say that, hey, I'm going to replace that by something. And it's going to be pizza dot. And since Rust is strongly typed, you can see that my IDE has detected that, oh, it's a pizza type. So I want to use the name string. So great. Now I've constructed my pizza with my pizza name. Maybe I want to do this to showcase that this will be replaced by my pizza name. So let's hit run. And cool, my pizza name is my pizza. Great. Now maybe we want to add more fields. Let's say I want to have a price, which is gonna be an int. So when I construct my pizza, no, I cannot compile anymore. So if I click run, as Rust once again is strongly typed, the compiler will prevent you from compiling because you know that pizza has now two fields, name and price, and price is missing. So this is maybe one of the great advantage of using Rust. You know at compile time that your program won't run because it's not valid code. You specify two fields, but you only put one. So that's definitely not okay. I need to first get rid of that. And I need a price. So let's say 10. And now I can compile. So I can update the print statement to say my pizza name is, and the price is pizza.price. And if I rerun it, great. Now I have my pizza and the price is 10. Maybe I want to add another field, let's say a list of toppings. In Rust, the array is represented by a vector. And a vector has a template type. It means that we need to specify what kind of type we want in our array. So here it's going to be a string. So if I want to define a vector, we can say toppings. It's going to be vect. This is what we call a macro. It's already defined for us, so it will create a vector. And maybe a string from topping 1 and topping 2. Now I have my list of toppings. Once again, if I hit run, this won't compile because I don't have a topping field defined. So I need to say toppings will be equal to toppings. If I run, that's fine. You can notice that topping equal toppings might be a bit overkill. So what we can do is just set toppings. Rust will infer that toppings equal toppings, so you can just write topping, and it will compile. And now I have to update the print statement. So you see that it's a bit annoying if I have 3, 4, 5 fields. Maybe it's not super easy to debug. Fortunately, Rust has a very convenient way to debug this. So my pizza is, and what I want to debug is the whole pizza item. But if I compile, as you can see, my pizza does not implement the display interface. It means that there is no way for me to represent that as a string. So there's two options here. One is to actually implement the display interface, or what we can do is we can add an instruction here, which is derive debug. This will add something at compile time to say to the compiler, hey, now I can debug my pizza. So what can I do is I can add this interrogation point here to say my pizza is now, it's now possible to debug. So if I run it, now it's very convenient because I didn't have anything to do, just add this debug statement and boom, everything is debugged. So that's very, very, very convenient. What we can do now to be a bit more clean, we might want to extract this into a new file. So let's go and create a new file. Maybe it's going to be pizza, and I have my pizza here. Now the pizza is could not be found, so I need to import it. So first I need to import this module. So pizza is here. And since it's in another file, this pizza needs to be public because I need it to be public so I can import it into from the main file. So if I go back to the main, I can import the pizza. So as you can see, we have one module and one import statement to say, hey, I want to create a pizza. I want to import pizza, the pizza type from the module named pizza. So cool. Let's start to run it. And if we have a look at the output of this run of the build, it's not possible to build because now the name, the price, and toppings are private fields. It means that even if my pizza here is public, the different fields of this pizza are not public. So what can I do is mark this as public and save. And if I run it again, this will compile. But that's not a very good practice to have everything public. What can we do is we can remove this public and create an implementation of the pizza. So by creating AMPL pizza, it means that we are going to define a function attached to this struct. So let's go and create a public function, which we are going to call new. This will return a pizza. So we can create a pizza and return this pizza. Obviously, this constructor will need 3 different parameters. The first one will be a name. Then we need a topping list. It's going to be a vector of string and a price. So you can say name equal to name, toppings equal toppings, and price equal to price. Well, that's great. Now I have my implementation of the pizza. I've created a new function attached to this pizza. But yeah, once again, when you see name, name, topping, topping, price, price, what we can do is just get rid of that. And the compiler will infer that, okay, name is name, toppings is topping, and so on. So cool. Let's go back to main. And instead of having this, we are going to use the new function. It's going to take the string, the price, and the topping. And remember that the order of the parameter are really important. So we need the string, the topping and the price. If I run this, great. My pizza name is name, my pizza, topping, and price. So great. Now I have my pizza struct, which is public, but the field are private. So this is a great way to decouple the pizza from the main. So yeah, congrats. That's it for day 3. You can now define a specific object, export it into a different module, and create function attached to this structure. So stay with me and see you tomorrow for day 4. Have a great day.